When we think of AI accelerators, Nvidia's GPUs dominate the conversation, powering everything from research labs to enterprise clouds. But Amazon is quietly stepping into the arena with its own custom silicon, aiming to rewrite the rules. In this chapter we ask, could Amazon's chip actually dethrone the long-standing GPU king? On screen we flash AWS Trainium 2 die, a sleek rectangular slab packed with tens of billions of transistors. Next, a sprawling data center hums with rows of servers, each rack ready to host these chips. Finally, a bold VS graphic pulses, symbolizing the head-to-head battle between Amazon's silicon and Nvidia's H100 GPUs. The real test isn't just raw specs, it's ecosystem, software, and pricing. Nvidia's CUDA platform locks developers in, while Amazon bets on open-source frameworks and tight integration with AWS services. So we ask, can Amazon really beat Nvidia at its own game, or will the incumbent's moat prove too wide to cross? In the rest of this video we'll dive deep into benchmark results, total cost of ownership, and real-world case studies from early adopters. We'll examine whether Amazon's chip can truly disrupt the AI hardware market or if Nvidia's dominance will endure. We'll also look at power efficiency, scalability, and the strategic implications for cloud providers. Amazon doesn't rely on off-the-shelf GPUs for its AI workloads, it designs its own silicon. The family includes Trainium, built for model training, and Inferentia, tuned for inference. These chips are purpose-engineered to run AWS AI services efficiently, giving Amazon control over performance, cost, and roadmap. Think of a traditional GPU as a Swiss Army knife, versatile but not optimized for any single task. Trainium 2 and Inferentia 2 are more like a custom-built assembly line. They feature dedicated matrix multiply engines, massive on-chip memory bandwidth, and data flow architectures that minimize movement of data, turning raw compute into focused AI work. Trainium 2 targets the heavy lifting of training large language models, delivering up to 100 teraflops of BF16 compute. Inferentia 2 excels at serving those models, offering high throughput with low latency. Both are exposed to developers via EC2 instances, TRN1 for Trainium 2 and INF1 for Inferentia 2, and integrate directly with services like SageMaker and Elastic Inference. Because the chips are born inside AWS, launching a workload is as simple as selecting an EC2 instance type. The underlying hardware, drivers, and firmware are pre-tuned, and AWS handles scaling, monitoring, and billing. This tight integration translates to better price performance, often 30–40% lower cost per training hour compared to comparable GPU-based instances. When we talk about raw compute, the numbers tell the first story. Amazon's Trainium 2 delivers up to 100 teraflops of BF16 performance, while Nvidia's H100 offers up to 60 teraflops of TF32 compute, which can double with sparsity techniques. These peak figures set the ceiling for training workloads, but real-world performance depends on how efficiently each chip can sustain those rates. Latency and throughput matter most for inference, where milliseconds translate to user experience. Inferentia 2 targets sub-millisecond latency at high request rates, achieving roughly 1 millisecond per request at 1,000 inferences per second on a single chip. In contrast, an H100 can hit 0.8 ms latency but often requires larger instances to match the same throughput, affecting cost and scalability. Power efficiency separates the contenders in long-running data center operations. Trainium 2 delivers about 30 teraflops per watt under typical training loads, while the H100 hovers near 20 teraflops per watt. That 50% advantage means lower electricity bills and less cooling overhead for Amazon-based workloads, especially at scale. Finally, price seals the deal for many AWS customers. An EC2 TRN1 N.32's large instance, Trainium 2, costs roughly $3.06 per hour, whereas a comparable P4D.24's large, H100, runs near $32.77 per hour. Even after accounting for software and licensing, the cost per training hour can be 7080% lower on Amazon's silicon, translating to substantial savings for large-scale AI projects. Amazon's drive to build its own AI chip starts with a simple strategic goal: break free from reliance on external silicon vendors. By designing Trainium and Inferentia in-house, AWS can avoid supply chain shocks, secure long-term capacity, and align chip roadmaps directly with its cloud services. As AWS VP Dave Brown put it, owning the silicon lets us control our destiny and deliver more predictable performance to customers. Cost efficiency is another powerful motivator. AWS custom silicon delivers up to 40% lower cost per training hour compared with comparable GPU-based instances, according to internal benchmarks. That translates directly into lower prices for EC2 TRN1 and INF1 families, letting customers run larger models or more experiments without blowing their budgets. Lower operating expenses also improve AWS gross margins, reinforcing the virtuous cycle of price-performance leadership. Vertical integration lets Amazon tighten the feedback loop between hardware, software, and cloud services. Engineers can co-design Trainium 2's instruction set with the AWS Neuron SDK, ensuring that popular frameworks like TensorFlow and PyTorch run out of the box with minimal tuning. This tight coupling reduces latency, boosts utilization, and enables features such as automatic scaling that are hard to achieve when the silicon comes from a third party. Finally, owning the chip opens the door to capture a larger share of the fast-growing AI market. AWS reports that AI-related revenue is growing at over 40% year-over-year, and offering differentiated silicon helps attract startups and enterprises seeking cost-effective, scalable training platforms. By providing a compelling alternative to Nvidia's GPUs, Amazon can lock in workloads that might otherwise go to competitors, expanding its total addressable market in AI. When Amazon offers its Trainium 2-based EC2 instances at a fraction of the hourly cost of comparable GPU instances, competitors feel pressure to cut prices. Nvidia may respond with discounts, bundled software, or new pricing tiers for its H100 and upcoming Blackwell chips, potentially igniting a price war that benefits AI developers but squeezes vendor margins. Developers now weigh hardware choice not just on raw performance but on total cost, software familiarity, and cloud lock-in. Amazon's Neuron SDK provides drop-in support for PyTorch and TensorFlow, reducing migration friction, while Nvidia's CUDA ecosystem remains dominant for research. The decision increasingly hinges on workload-specific cost-benefit analysis rather than brand loyalty alone. If AWS captures even a modest share of the AI training market, Nvidia's market share could dip from its current 80% dominance. However, Nvidia's moat, deep software stacks, broad OEM partnerships, and a developer community of millions, means any share loss will likely be gradual, prompting Nvidia to accelerate innovation and possibly diversify into cloud-owned silicon. Amazon's move signals to other cloud giants that custom silicon is a viable competitive lever. Google's TPU v5e and Azure's forthcoming Maya 100 AI accelerator are already targeting similar workloads, hinting at a future where hyperscalers vie not just on services but on proprietary hardware. This multi-front competition could drive rapid advances in AI chip efficiency and accessibility. The AI hardware landscape is shifting from a single-vendor monopoly to a diverse ecosystem where cost, software, and cloud integration all shape adoption. As these forces play out, we'll see faster innovation, lower prices, and more choices for builders everywhere. If you found this analysis helpful, smash the subscribe button, ring the notification bell, and drop your thoughts in the comments. Who do you think will come out on top?